Hi, guys. It's me, Mr. Bertoch, your incredibly handsome science teacher. And in this video, we're going to talk about El Nino and La Niña. Once upon a time, there lived in the land of South America humans. That's right. I bet you didn't know there were humans in South America, but there were once. Not anymore. Well, okay, yes, there still are. But there were humans, and they lived in South America for many centuries along the coast where our story takes place. There were fishermen. And let's talk about the 1800s because they spoke Spanish, and that wasn't something that happened, uh, well, in the 17 and 16 and 1500s, I guess. But prior to that, they didn't speak Spanish. And this story is about people who speak Spanish. So 17, 16, 15, and 1800s, that area, there were humans and they spoke Spanish. Yay. And they were fishermen. And they fished on the ocean off the coast of South America and the Pacific Ocean. And these fishermen, these fisher humans, they were not mermaids. They were not fish humans. They were fisher humans. They caught fish for their families and their communities, and that is how they fed their families. But they noticed something. They noticed that every 5 to 7 years, sometimes 3 years, but on average, every 5 to 7 years, their catch of fish got significantly less. And they learned that because their lives depended on it. So, and it was a clear and obvious pattern that was repeating over and over again. They learned that they could pretty much count on, like clockwork, that they would not catch a lot of fish in a particular season. Like I say, on average, every 5 to 7 years, but sometimes as often as every 3 years. And they named this phenomena El Nino, which was part of their Catholic faith. El Nino El Nino means baby. Es una palabra que significa baby en español. And it refers to the Christ child, which was part of their Catholic faith. And so they attributed the lack of fish, and that makes sense if you think about it. Fish having to do with one of the miracles that is described in the New Testament. So they attributed the fish and the lack of fish to the Christ child. Well, now zoom up the map to another group of ancient humans who were living in the Western United States and who had communities there. And these humans noticed a similar pattern. They noticed that every 5 to 7 years, but sometimes as soon as every 3 years, there was a drought cycle. There was a cycle of lots of Western United States is pretty dry. It's a place that is either arid or semi-arid. That means desert or mostly desert. But every 5 to 7 years, there would be a really wet year or a more wet than normal year, but sometimes as soon as every 3 years. And of course, they didn't know because they weren't in contact with the people down in South America, but it was the same year. The same year that the people in South America were not getting a super allottiness of fish, the people up in the Western United States were getting a lot of rain. That was the year they were getting a ton of rain. Well, what was happening? What could cause such broad scale changes that are so different from one another? Why were the fish dying off the coast of South America in the same year that the people up in the Western United States, it wasn't called Western United States at the time, but in that region that we now call the Western United States, the people there were getting a ton of rainfall. And actually, in the Eastern United States, as well, is impacted in that it gets a little bit drier. So these broad scale changes, what is causing them? Well, we didn't know the answer to that for a very long time. In fact, in my childhood, we still didn't know the answer. I can remember being taught and watching videos, nature videos, because we didn't have YouTube. We were not fortunate enough to have super handsome science teachers doing videos like you are. So you are much luckier than me, because I couldn't watch myself in a video. So be very grateful for that. But anyway, but I can remember watching videos on like PBS where they said that we don't know what causes El Niño and La Niña. In fact, I remember watching the weathermen say, we suspect maybe it's caused by this or that, but we don't really know. But this is a problem that has been largely solved by science in my lifetime, which is kind of cool. So here is what happens. Let me explainate it to you. I shall explain to you now the causes of El Niño. And incidentally, La Niña, I should mention too. La Niña means the girl child. It's just the opposite of El Niño. So when we get the period where the fish die and there's a lot of rain in Western United States, we call that El Niño. When we have the opposite extreme, where there's a bounteous crop of fish off of South America in the Pacific Ocean, and it's dry in the Western United States, we call that La Niña. All right, then, what's causing it? So the first thing you have to understand, and by the way, I'm now going to say my favorite thing to say. In another video, I talk about a lot of the things that are that I'm going to reference in this video. And it would be a good idea to watch those videos, because there's a lot of things that are better explained in a lot more detail. For example, I'm going to talk about something called gyres, and I just said that wrong. Gyres, and what else? Subtropical highs, and some of the oceanic currents. So it would be a good idea to watch my videos on those topics to better understand what I am describing to you. And by the way, if you watch all my videos, like all of the hundreds of them, you are going to be such a good grammaticalitarian, because you are going to speak English as well as I do after you watch all these videos. And I clearly speak English so well. So anyway, yeah. So go watch those videos. Not only will you learn better grammar, but you will also learn about all the things. And remember, I am not your grammar teacher. I am your science teacher. And so I'm not your science teacher. I might be your science teacher. But anyway, I am a science teacher. I am not a grammaticalitarian. So anyway, let's talk about El Niño and La Niña, shall we? What causes it? So let's start with subtropic highs. Around the subtropics, in every ocean basin, there is something called a subtropic high that forms. And it would also be a good idea to watch my video on the Coriolis effect. So that'll help you understand as well. So these subtropic highs, because of them, and I'm not going to go into detail exactly in this video what's causing them, okay, but the result of them is that the water in each ocean basin begins to rotate. In the northern hemisphere, the water in each ocean basin rotates clockwise. And I had to think of that. I had to envision it. I'm like, wait, what direction does it go? And I imagined it in my head. And by the way, that's an important skill in science. It's better to envision things than to memorize things. So if you understand something and you can envision it, that's a much better thing, because then you really understand it than just having it like memorized. If you memorize it's clockwise in the northern hemisphere, but you can't really envision that, that's less good. That's less goodly than if you can close your eyes and be like, okay, wait, what way does it go? And imagine it. But anyway, it is clockwise in the northern hemisphere. And in the southern hemisphere, it is counterclockwise. So we're talking about the southern hemisphere, and specificamente, we are talking about the Pacific Ocean, the South Pacific Ocean, where there is this massive gyre that is rotating around a subtropical high. Gyre, the word gyre, it sounds like gyrate, gyration. It's like gyrating, right? So it's going counterclockwise. Is that counterclockwise? I don't know. Anyway, it's going counterclockwise. It's moving. I think that was clockwise. Anyway, and the water, so it moves up the coast because it's going counterclockwise. It moves up the coast of South America, bringing cold water from the poles along the coast of South America. And then it goes across the equator over towards like in Indonesia and Australia. Along the equator, it gets warmed up, and then some of it comes back down around Australia, back down to the pole, and cools off, goes along the pole, gets cooled down again, and then comes up South America again. So it's spinning over and over and over and over and over. Well, fish like cold water, because cold water, in another video, you're welcome. In another video, I talk about how there's this thing called a thermocline that creates a barrier that makes it so fish have a hard time getting food. Watch that video if you want to understand. But fish like cold water because there is no thermocline. And so when there is cold water, you have a lot more fish. This is why fishing industries tend to focus in the poles where there's a lot of fish. There's a lot more fish in the poles than there are in the warmer parts of the Earth's oceans. So when you have cold water, because of this gyre that's bringing all this cold water up the coast of South America, you're going to have a lot of fish. Well, notice, and this is what we didn't understand when I was a wee little child, when I was a wee little half-size human like you. And we do understand now because somebody smart figured it out. Notice that the islands of Indonesia and Australia are kind of like a little hook, and they catch a lot of the water as this gyre is spinning around. And as the water goes up and across the equator, it gets warmed up by the equator, on the equator, because that's warm. It's getting a lot of sun. And some of that water gets hooked. It gets caught by Indonesia and Australia. And it can't get through super well. It's kind of like a dam. And so it dams that gyre up. And the water slowly over several years actually rises. And it can get up to 10 or 11 inches higher around Indonesia over the course of 3, 4, 5, maybe even 7 years. But on average, 5 to 7 years, but sometimes 3, depending on circumstances. And that water's really, really warm because it's along the equator. So we get this mass of warm water that builds up over a few years and along this little hook, this net, this dam that is Indonesia and Australia. And eventually there's so much warm water there that it kind of shuts the gyre down. It kind of shuts down. It gets too warm and it breaks down the gyre. And so all that warm water, well, what does it do? You now have like a little mass of warm water that's higher than everywhere else around it. And it was being pushed over by the gyre, but the gyre, when it shuts down, there's nothing to hold it back anymore. And so it all flows backwards, and it flows up against the coast of South America and into also the areas around the Pacific Ocean along North America. So all that warm water floods backwards. Well, what happens to the fish? Those poor little fish, because they now can't get any food because there's something called a thermocline. Go watch my thermocline video to see what the heckins I'm talking about when I say thermocline. But just know that means the fish can't get food, and so the fish starve. The fishermen can't catch food now because there's way less fish. And so they notice, hey, we don't have any fish. And the weather in North America is altered because the Pacific Ocean is so much warmer that you get a lot more storms that form. In another video, you're welcome, I talk about how warm water, warm temperatures create low pressure systems, which are basically storms. Go watch that video, will you? And you shall learn about why that would create more weather. But know this, that when the ocean is warm, then it creates more weather systems, and those move in across North America and create a lot more rain. So that year, as all the water, the warm water that was trapped by Indonesia and Australia that form a dam in the gyre system, that all flowed backwards, that year, is all that warm water is flowing backwards, you get more weather in North America and way less fish along the coast of South America, and that is called El Niño. Pero lo que pasa cuando what happens when there is the opposite of that, when the gyre is functioning as it should, and it's spinning and spinning and spinning counterclockwise, and there's cold water running up the coast of South America, and then there's lots of fish, and the west coast of South America is nice and cold, and the west coast of North America is nice and cold, and so you're not getting a lot of weather coming in, so it's more deserty, and there's plenty of food for all the wonderful fish that are inhabiting those coasts, and so there's lots of fish. And that is El Niño and La Niña. Sí, es cierto. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.